All right, welcome to pre-calculus. For this, if you can't see because of the glare, it's getting nicer outside, so sometimes the sun will hit this. Let me know so I can move this whole board just a tad. We're learning about polar coordinates. Last time we learned about graphing them. Today we're going to learn how to put them in polar form to rectangular form back to polar form. I would say rectangular form is like equations of a graph. So something you typically see like y equals x equals something something. And then that's rectangular form. And polar form, it's always a coordinate. It's always the radius. That's what I call it. The radius, and it's the degree there. For example 3, here, well, before we do that, up there on the board is a conversion. So to go from one form to the other form, here it's polar to rectangular. So here, to go from polar to rectangular form, you have to put it in this format. So x is equal to r cosine theta, y is equal to sine theta. And then from rectangular to polar form, which we don't do often, but when we do, it's going to be r squared equals x squared plus y squared. And then another way is tangent theta is equal to y over x. So for the first one, example 3, it says put it in polar form. Oh, this is in polar form, and put it to rectangular form. So rectangular form is something you typically see when you're graphing equations. Here, from polar form to rectangular form, what we know whenever we have our commas here, this is always our r, our radius, and this is always our degree, it's a theta. So therefore, we already have two parts of it. So let's go ahead and find what the r is first. So what we're going to do here, we're going to use one of the two equations here. I'm going to use, which one am I going to use? Making sure I have it correct here. Okay, we're going to use both of them. So in this case here, for polar to rectangular, so we're focusing on this side here, not that side. So here, we're going to find what x is and what y is. Normally, it's x is equal to r cosine theta. Y is equal to r sine theta. We already have two parts of it. We have the radius and we have the measurement. So if we plug it into each one, we have x is equal to r, which is 4, cosine of the given angle, and that is 2 radians over 3. Now let's keep on going. So now we have x is equal to 4. 4 times the cosine of 2 radians over 3. If you grab your unit circle, 2 radians over 3 is 120 degrees. So now they're asking you for the cosine of 120 degrees. Cosine is always the x coordinate. So the cosine of 120 degrees is negative 1/2. So now we have 4 times negative 1/2. Our x is now negative 2. Our y here is r times sine theta. So now we have to go ahead and find it. So now we go ahead and plug in what we know. Oops, it's 4. Radius is 4. Then we have the sine of the angle. The angle is 2 radians over 3. And 2 radians over 3 is 120 degrees. Now, to simplify even more, we do 4 times sine of 2 radians over 3. It's the y coordinate for 120. And that is radical 3 over 2. And then you simplify it. So 2 can go to 4 twice. You get 2 radical 3. So your answer for this one is a coordinate, is just one mark on the graph, which is negative 2, comma, 2 radical 3. Simple. Now let's do example 4. From rectangular back to polar form, we have to make sure we have, remember it's the radius, comma, and it's the degree given. Now for this, we have to use rectangular form to polar form, so we're going to be focusing on this here so we can put it back into polar form. The two things that we need for polar form is the radius and the given angle. So let's go ahead and find the radius first. According to this, the radius equation is r squared is equal to x squared plus y squared. Luckily over here, we have a coordinate. We have what x squared and y squared is. So r squared is equal to x squared, which is 2, plus y squared, which is negative 2. 2 squared plus negative 2 squared, that's 4 plus 4. That gives us 8. To get the r completely by itself, we square root it. So now we have plus or minus 2 radical 2. So radical 8, simplify as much as you can. So you get plus or minus 2 radical 2. For our radius, we have 2 of them. We have positive 2 radical 2 and negative 2 radical 2. Keep in mind, when you always graph negative radiuses, let's say it's going to be over here, we always make a dotted line on the other side. here we're gonna have two separate graphs. We're gonna have two different types of graphs in this equation. Now, we found what the r is. Let's go ahead and try to simplify it even more. Let's try to find the degree given. Now, here, we're going to use a tangent. We're trying to find the angle by using the tangent form here. So the tangent is equal to y over x. We know that y is -2, x is 2. So we have the tangent of the angle is equal to -1. That means whenever you have 1 or -1, especially for tangent, especially when we're doing unit circles, that means the same number divided by the same number itself will give you 1. Or the same number, so one is positive, one is negative, will give you -1. If I look in this graph, there's only 4 types of coordinates that have the same x and y value with just different signs. And that is 45 degrees, radical 2 over 2, radical 2 over 2. We have here negative radical 2 over 2, comma radical 2 over 2. We have here, they're both negative, and we have here, one's positive, one's negative. If we want one to equal -1, we have to make sure we choose from those 4. And what I have is these 2 here. I have here, negative number divided by that same number itself will give you -1. And this itself, if you want to double check, just divide it. And here you'll have a -1. So my possibilities for a tangent being equal to -1 is 3 radians over 4. And the book has it as negative radians over 4. You could use 7 radians over 4. It really doesn't matter. It's the same line. It's like coterminal angles. It's the same exact line. If you notice here, that's 7 radians over 2, or over 4. It's the same exact one. So they just use negative. Now, to put into polar form, keep in mind we do have 2 answers for this. We have one with a positive radical 2 over 2 and one with a negative radical 2 over 2. So when we were to graph these, the first one, let's have radical 2 over 2, we have positive. So when we have positive 2 over 2, we have to choose one of these forms that does not coincide with the other one. So let's say we have to keep the negative radical 2 over 2 in mind. I think for me, I would start with the -1 first because you will end up with coinciding angles. When I did the first time, I kept making the same angle over the same angle, and you don't want that. You want 2 opposite angles. So if we want -2 radical 2, let's say we're going to use the first one, 3 radians over 4. We know 3 radians over 4 is 120 degrees. So we have, this is 3 radians over 4. Keep in mind, whenever you have a negative radius, we have to make sure we have that dotted line. So this right here is negative radians here. Let's say for the positive one, let's say 2 radical 2 over negative radians over 4. If we were to graph this on the same one, negative radians over 4 is right here. If we were to graph the positive 2 over 2, that would be this line here. So now we have 2 opposite lines. If, let's say we switch it. So let's say we flip it. So 2 radians, or 2 times radians 2. If we graph that with 3 radians over 4, so 2 radians over, this is 3 radians over 4. So let's say 3 radians over 4, and we say this one is 2 radians over 2. Now let's say we switched it here, we have -2 radians over 2 with negative radians over 4. So when we graph radians over 4, that's going to be over here. And this is negative radians over 4. If we were to graph the -2 radians over 2, remember it's always the opposite line. But keep in mind, we already drew a line there, and that means it's going to be the same exact line twice. We don't want to use the same exact lines. We want opposite sides. We want them to show both of the coordinates here. So that's why I try both of them out. And again, you can use negative radians over 4, or you can use 7 radians over 4. They're both the same thing. And that's how you get your 2 answers. Just make sure you have 2 polar coordinates when you graph it in one graph. It shows both of them, not just one. Example 5, rectangular to polar. So here now it gets a little bit more complicated. They want all of this to show into rectangular to polar coordinates, and this is what you deal with a lot more than example 4. Here we have x squared equals 4y. In this case here we have to go step by step, and we have to, this is example 5, yep, we have to go ahead and put this in polar form here. So now they want this in polar form. So what you do when we want things in polar form, we go ahead and simplify step by step, and we go ahead ahead and identify what x is and what y is here. According to this, for polar form, x is equal to r cosine theta, y is equal to r sine theta. So in this equation here, we can go ahead and plug in what x and y is. X squared, or according to this, it's r cosine theta. So r cosine theta squared, because it was x squared, equals to 4 times y, and then y is considered r sine theta. For polar coordinates, you're going to use a lot of substitution. Now, we have a squared here. We can go ahead and distribute the squared. That means the r is squared, and then the cosine theta is also squared. And this is just for r sine theta. Now, let's go ahead and, if from this point, you always want it to make it look like this top equation here, trying to get the r by itself. So whenever you're having a rectangular to polar form, let's get the r by itself here. So to get the r by itself, they both share a common r. I'm going to divide both sides by r. This cancels out here. I have 4 sine theta. And then r squared, 2 minus 1, you just get r cosine squared theta. Here, we want to get the r by itself. So divide both sides by cosine squared theta. And from this goes back to using one of the identities. It's not going to use a more complicated ones. They're using the practical ones like the tangent equals y over x and all the reciprocal functions. Here, if I do whenever I say sine over cosine, I always think of the tangent. Remember, that goes back to the last lesson or the last chapter that we did. And we know that sine over cosine, so let's say sine over cosine. We know sine over cosine is equal to tangent. But keep in mind, it's sine over cosine squared. That means there's 2 cosines. So if I separate it, I can have sine over cosine. Since the cosine is in the denominator, I'm going to separate it to a different fraction. So sine theta over cosine theta. Now, this is equal, so I'll bring the 4 down. Sine over cosine is always equal to tangent. So tangent theta. And then here it says 1 over cosine theta. I'm going to put squared because I separated, so there's 2 of them. 1 over cosine is a reciprocal function of whatever cosine is. And cosine, the reciprocal function of that is secant. So the book has 4 secant tangent, but it's 4 tangent secant. Kind of undo it, and you want practical trig functions here. So now this is your answer here. You want the radius by itself. Example 6. In this case here, it deals with converting from polar to rectangular. So this is like what the kind of equations that you see. Here, if r is equal to 5 secant theta. In this case here, for example 6, you want to get the r by itself, and you want to get the r squared. So in this case here, the first step would be to square the whole thing, because we want an r squared, and that's going to be for all of them. So then we have r squared is equal to 5, yeah, we'll do that, secant squared. So when we do that, did I write them down? Oh no, that is wrong. Here, in this case here, we're going to simplify it a lot easier. So r 5 secant theta. Here we have secant theta, and let's go ahead and try to put it in like sine or cosine form. So we have r is equal to 5. Secant is considered 1 over cosine theta. So in this case, we don't have to do the r because it's already by itself on one side. So in this case, you don't have to do as much. Here we have 5 times 1 over cosine. We want to keep it in practical terms. Here, let's go ahead and try to make this even less complicated. If we multiply both sides by cosine theta, we cancel this out, we get r cosine theta is equal to 5. If you notice here, r cosine theta is one of our identities from the beginning, and that is equal to, cosine is equal to x. And there it tells you what kind of graph it will be. In this case, this graph x equals 5, you see on your book, it's actually a vertical line. It creates a type of graph. So in this case, we want to undo it because we want to keep it in terms of sine and cosine, and therefore we have this here. B, r is equal to 2 sine theta. Keep in mind when we're using these type of coordinates, you have to make sure the r is there in order for you to substitute. Here, it looks like we can try, the sign's already there, so we don't have to multiply it by anything, any reciprocal function. So here we are actually going to multiply it by r. We're going to have r squared is equal to r times 2 sine theta. When you multiply that out, we have r squared is equal to 2r sine theta. And now that looks like one of the identities there. So we have r squared is equal to 2r sine theta. 2r sine theta is equal to, I keep moving this. Let's move it there. 2r sine theta is equal to y. Now, we look at what r squared is. R squared is equal to, and this is looking at this function here, r squared is equal to x squared plus y squared. So we're substituting r squared. But remember, it has to be a squared in order for you to substitute. And now we have x squared plus y squared is equal to 2y. Whenever I see x squared plus y squared, I think of an equation of a circle. Meaning, bring everything on one side. So we have x squared plus y squared, and we're going to subtract both sides by 2y. So we have minus 2y equals 0. You could leave it like that. I have seen different videos where they just left it like that, but we're going to go ahead and do what the book has it. If you leave it like that, I think it's fine. But then if you want to keep going, we have the y's here. We could go ahead and simplify this, because remember, everything's always in x squared, and the other one's in y squared. It's always in terms of squared. So here, we can have y squared, but to find that number here, we have to complete the square. So it's b over 2 squared. B is considered negative 2 over 2 squared is equal to negative 1 squared. Remember that number before you square it, that's the number that's going to be between the parentheses. That's going to be y plus 1, so it's always y minus, oh no, this one's y minus 1. So it's going to be the sign with it. So it's going to be y minus 1 squared is equal to, and before you do anything, negative 1 squared is 1, and you add 1 to both sides. Well, in particular, you have to add it to the right side, so you get this equation here. But again, you can just leave it in terms of everything by itself on one side. X squared plus y minus 1 squared is equal to 1, and the graph on the book has it how you would graph it, which is an equation of a line. Now the last one, r equals 2 plus 2 cosine. Here, we want to make sure we get the r. The r is by itself, but there's nothing here that looks similar to the first coordinate here. We're going to go ahead and multiply r into both sides. We have r squared is equal to r times 2 plus 2 cosine theta. If we multiply the r out, we get 2r plus 2r cosine theta. Now, whenever I see r cosine theta, I can substitute it for something. And in this case, I'm going to substitute this as well. R squared is also equal to x squared plus y squared. 2r is just 2r. And then plus 2 times r cosine theta. R cosine theta is considered x. Now, you have x's here, you have x's over here. Let's go ahead and combine it. Let's go ahead and move it. Now we have x squared minus 2x plus y squared is equal to 2r. Whenever we're working these type of problems, we need to make sure we have the r squared. We squared it the first time, but we always want to make sure we have it in terms of squared. So we go ahead and square both sides. Now you have, I'm not going to multiply this out, you don't have to. So this equation squared, I'm not going to do anything, I'm not going to solve it out. And here, when we square this, we get 4r squared. And then we have that, and then we can substitute r squared again. I'm going to rewrite this all over again. Squared is equal to 4 times x squared plus y squared. And you can't move this around because you would have to simplify this out and then bring it to the other side and